Welcome to the ChopMan tutorial series. Based on the beloved classic arcade game Pac-Man, this project was created to be an easy-to-follow step-by-step guide that would give you the tools, techniques, and experience of creating a full game from start to finish. We have made all the original assets that we created for the game completely free. If you wish to follow along step by step, you will need to first download the ChopMan project files, both of which can be downloaded in the downloads area of the tutorial site or from links in the description. In this video, we'll be showing you how to set up the player character for the ChopMan game. For this project, instead of root motion or animations to drive the character's movement, we'll be using a combination of blend shapes, scripts, and triggers to cue the character's animation. For the first part of this video, we'll be setting up a script that can make our character automatically blink. The script, much like the camera fade script we created in another video series, is the kind of script that we recommend that you save and not only use with this character in game, but for characters in any other game you develop. And while not 100% necessary for our game to function, small nuances such as this can easily help bring a character and game to life when viewed by the player. Something that you may have noticed in both our Chomp and Ghost characters is that they don't contain any native animations in the FBX files. Instead, they contain blend shapes. For those of you that are unfamiliar with what blend shapes are used in 3D to interpolate between different sets of geometry. Blend shapes are most often used in facial animation to transition between expressions or to make a character speak during dialogue. Since we'll be making a prefab of our character, we don't need to add our character to our level 01 scene just yet. So open a blank scene and drag the Chomp character into the hierarchy. The Chomp character can be found in the Mesh folder under the Character subfolder. Once you bring the character into the scene, we should reposition the camera so it can view the front in the game screen. Select the character and hit the F key, which is the hotkey for focusing the viewpoint on the selected object. If we look at the Chomp child object, Chomp Mesh, we can see the blend shapes that we have for this character. The two blend shapes we see on the Chomp Mesh are blinking, as well as one for closing the character's mouth. To begin, go into the script folder and create a script called Blinking Script. To do this, right-click anywhere inside the project window and in the drop-down, go to Create and click C# Script. Once you have the script created and named, drag it onto your character and assure that it is on the parent game object, not the Chomp Mesh child game object. With the script now on the Chomp character, double-click the script to go into the script authoring software. Let's remove our script notes. The script notes are always highlighted in green and usually begin with 2 forward slashes. Keep the start and update methods since we'll be using them in this script. The first thing that we want to do within our script is we want to define our character. Since this script is attached to the player, we can make our character game object variable private. Create a game object variable and name it character. Next, in the start method, define the character game object by typing character equals this.gameObject. This essentially tells Unity to take the object that houses this script and store it as our character game object. The next thing we need to do is to create and define a skin mesh render variable. Under the character variable at the top, type skin mesh render and name it character mesh render. Next, define the character mesh render in the start method under the character line of code. To do this, type character mesh render equals character.getComponent less than, skin mesh renderer, greater than, parentheses. In order to test our script, let's create and test out the basic functionality of the eyes closing. We create a public method and call this method test. So type public void test parentheses, then open and closed brackets. Within the test method, we want to set the blend shapes in our skin mesh renderer to 100, which means that our character's eyes will be closed. To do this, type character mesh render dot set blend shape weight parentheses, and inside the parentheses, we need to tell Unity which blend shape to set and to what amount. In this instance, our blend shapes are defined based on an array. Arrays start at 0 and go to 1, 2, 3, 4, and so forth. Since the blink is the first blend shape, its index will be 0, and the weight we want to set is 100. Since we plan on testing our script, we should also ensure that the eyes will open. Rename test to test closed and copy the test closed method and code within it. Then, place it outside the test closed method. Rename the pasted method to test opened and set the blend shape weight to 0. In order to access these methods from the editor, we need to create what's called a context menu. Above the test open method, type open square bracket context menu parentheses, and inside the parentheses, type test open in quotes. Create another context menu just above the test closed method. Since this is the foundation of our script, let's test our script out in Unity before we continue. At this point, we can now save our script and go back to the Unity editor. Within the Unity editor, if we go on our debug menu, we can see the two variables we created. In order to get to our context menu items, by right-clicking on the script in the inspector, you should see that you have a test close as well as a test open at the bottom of the dropdown. With that in mind, let's hit play to begin testing our script. In play mode, if we look in our debug menu, you should notice the character mesh render is empty. The reason for this is because our skin mesh renderer is actually on a child game object, not on the parent game object, which is where the script is attached. So to fix this, we need to go back into our script editor. In our start method, in the character mesh render line of code, after character, simply type transform.getChild parentheses .gameObject, and inside the parentheses, type 0. Since the getChild operation views the child game objects in terms of an array, the index of 0 simply tells Unity to get the first child game object under the parent. So essentially, what our start method is saying is get the object that the script is attached to and place it into the character variable. Next, use that object in the character variable and find the first child under it, then take its mesh skin renderer component and place it into the character mesh render variable. That said, let's save our script and once again go into the Unity editor to test it out. With debug mode enabled, you should now see both the character and character mesh render variables are no longer empty. Right-click on the blink script component and select Test Closed from the dropdown. We can see the character's eyes are now closed, and in the skin mesh render component, the blend weight is now set to 100. Next, right-click on the blink script component and select Test Open. Our character's blend weight is now set to 0 and the eyes are now open. At this point, we can see we have the basic foundation for the logic of our script. So let's go back into our code editor and create the lines of code to call these functions automatically. Before we begin creating our code, let's first look at the logic that we need to implement and make the character blink automatically. We've established that the main part of the logic is going to be setting our blend shape's weight to 100 and then back to 0. However, we want this to happen gradually, opposed to simply snapping open and snapping closed. We also want there to be a brief pause between blinks. So first, we need a float variable to represent our current blend shape weight. Second, we need the 2 additional floats to represent the weight minimum, which is 0, and the weight maximum, which is 100. Third, we need 2 more additional floats to represent the character's blink speed and another to represent the amount of time between blinks. With that said, let's begin creating our first set of float variables. For our first float, we're going to name it blink weight. Our second float will be public and we'll name it blink speed. Our third float will be named max blink weight, and our fourth will be named min blink weight. Lastly, we'll create a public float variable that we'll name blink pause. Since we've established 100 as the maximum value of a blend shape, set the max blend weight to equal 100. Likewise, set the min blend weight to equal 0. For those new to working with C# code, placing F at the bottom of a value indicates that the value is or should be treated like a float. There are a number of suffixes aside from F that can be used in C#, such as L, D, and U, just to name a few. However, for our case, F is the only one you'll need to understand how and when to use. With our variables now in place, let's begin implementing our logic. First, in the update method, we'll need 2 if statements, which will determine whether the character should close or open his eyes. Since we'll be using our blink weight variable to get and set our character's blend shape weight, to do this, we'll need to compare the current blend shape weight with the max and min blink weight values. We'll start with the code we'll use to make the character's eyes closed, which will be using our max blink weight variable. We'll use time.deltaTime as a way to gradually set the blend shape weight so the character's eyes don't simply snap open or closed. To implement this within our script, we can simply type blink weight is equal to blink weight plus time.deltaTime. We also need to set the blend shape weight to get its value from our blink weight variable. Next, we'll create the code to make our character's eyes open again, which will be using the min blink weight value. This will also use time.deltaTime to gradually set the blink weight value, with the only difference being, instead of adding it to the value, it will subtract it from the value. Something to note is, instead of typing blink weight equals blink weight minus time.deltaTime, we could simply type blink weight minus equals time.deltaTime. Typing it this way is called a shorthand notation or a compound assignment. So typing blink weight minus equals time.deltaTime means the same thing as saying blink weight equals blink weight minus time.deltaTime. It's simply a faster way of typing it. At this point, we have two conflicting statements, since we're both telling Unity to add and subtract the moment our blink weight value gets higher than 0. We need to add a Boolean variable that we'll name isBlinking to stop this conflict. We'll now need to use our Boolean variable to enable our max blink weight if statement. Additionally, we'll use an else statement to enable our min blink weight if statement. Just like with the min and max blinking weight, instead of typing if isBlinking is equal to true, we can simply abbreviate the code to read if isBlinking. Now that the first part of our code is complete, let's go into Unity to test it out. Make the isBlinking Boolean public, save your script, and return to the Unity editor. If we hit play with our debug menu enabled and click the isBlinking checkbox, we can see that our blink weight is slowly increasing. And by looking at our character's blend shape weight, we can also see it slowly increasing at the same rate. However, by simply using delta time, the speed in which our character blinks is extremely slow. But by using our blink speed variable, we can increase or decrease the speed in which our character blinks. In order to do this, we simply need to multiply our blink speed by time.delta time. In the Unity editor, set the blink speed to 1000. In play mode, by checking and unchecking the isBlinking checkbox, you see that the character now quickly but gradually opens and closes his eyes. In our opinion, 1500 is the ideal blinking speed for this character, but feel free to set the number to whatever speed is ideal to you. That said, since our blink speed won't change throughout the game, we'll set the variable to private and simply define it within the script. For our last and final lines of code, we need to create a method that will automatically toggle our isBlinking Boolean. We also want this method to take into account the blink pause value we're going to set. The simplest way to do this is by using a coroutine. For those that are unfamiliar with working with coroutines, within Unity, a coroutine is a type of function or method that can stop its execution until some time or certain conditions are met, at which point it continues from where it had left off. Creating a coroutine is a bit different than creating a regular method. Instead of typing void, then the method's unique name, we'll type IE numerator, then the method's unique name. In this case, we'll simply name our coroutine blink. Additionally, unlike the standard methods, a coroutine must always have a yield instruction finish. To do this, within the coroutine, type yield return null and end that line of code with a semicolon. By default, a coroutine is resumed on every frame after its yield's return. However, one of the greatest benefits of coroutine is the fact that we can introduce a time delay using wait for seconds. To do this, type yield return new wait for seconds parentheses, and inside the parentheses, we can pass in the blink pause float variable. Next, we'll define our isBlinking value as true. we'll use our wait for seconds once again to allow enough time for our character's eyes to close. Then, we'll define our is blinking as false to allow for our character to reopen his eyes. Unlike start or awake, a coroutine doesn't start automatically. So in the start method, we'll need to start our coroutine. In order to do this, type start coroutine, parentheses, and inside the parentheses, define the name of your coroutine as a string. Unlike the update method, coroutines don't continuously run over and over after they've been called. So we'll need to create a way that will allow our coroutine to continuously run once we initially call it. So we'll need to loop the code in our coroutine. To do this, we'll first create a new public bool that we'll call cannotBlink. Next, at the top line of your coroutine, create a while loop by typing while, parentheses, and inside the parentheses, cannotBlink is equal to false. Let's also insert cannotBlink into our update method. Since the update method runs every frame, this will help in better optimizing our game. The shorthand for this is !cannotBlink. Additionally, by placing this in our start method, it can allow you to disable the blink if the need arises during development. With our blink script complete, let's go back into the Unity editor to test it out. Be sure to set your blink pause before or during play mode. With our blink fully functional, let's clean up our script before moving on to setting up our character. Set the isBlinkingBool to private and delete the two test methods we created at the start of the lesson. We can also create a range for our blink pause float, which will ensure it isn't ever set too high or low. To do this, above the blink pause variable, type square brackets, and inside of the brackets type range parentheses, and inside the parentheses, place the minimum and the maximum value you'd like the range to be, with a comma between the two values. Back in the Unity editor, we can see that we now have a range slider in the inspector, which allows us to easily choose the blink pause value. For the final step, create a prefab of the Chomp character by dragging him into the character subfolder in the prefab folder. If you don't have a character subfolder, you can easily create a new folder just by clicking anywhere in the project window and selecting Create Folder. In the second part of this video, we'll do the base setup of our Chomp character for our game. With the character prefab selected, at the top left part of the inspector, inside the dropdown, select Player. Player is a default tag which is included in Unity. But in the next lesson, we'll go over how to create your own custom tags for those that are unfamiliar with the process. With the character now tagged, go to Open Prefab. First, since we won't have any animations for our characters aside from our blend shapes, remove the animator component for the character. Next, add a character controller component. On the character controller, move the height to 1 and make the radius and the center y-axis 0.6. Next, add a sphere collider component. Make its y-axis 0.6 and its radius 0.65. Since the character controller will act as our physics collider, set the sphere collider to isTrigger. Save the prefab, and by dragging it into our scene, we can now see our character has both the character controller, spherical trigger collider, and the blink script. That completes our player blink script and character setup. In the next video, we'll set up our enemy characters, creating a dynamic floating effect and a script that allows them to glow and dynamically change colors with a single material. So be sure to join us in our next lesson of the ChopMan Games Made Easy tutorial series.